Alright, we are, like I said earlier, reviewing our objective from yesterday. Our objective is I will be able to order and classify real numbers using sets, classifications, and real-world situations. If you were here yesterday, this is basically just a review. First thing that we are doing is looking at our different classifications for numbers. First one is if I started counting. If I said count to 10, you would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's your natural numbers. Alright, so the first thing is my natural numbers. Next thing is the natural numbers plus 0. That's going to be your whole numbers. So whole numbers are just your natural numbers, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus 0. My integers are the whole numbers, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the opposites of those whole numbers. So negative 1, negative 2, negative 3, negative 4. Okay? Anything that can be written as a fraction, anything that can be written as a fraction is a rational number. Okay? A rational number is a number that can be written as a fraction. Now that's a fraction when you do not have 0 in the denominator. If it can be written as a fraction, it's a rational number. Now, when rational numbers are written as decimal, rational numbers, like we said yesterday, they're either going to terminate, meaning they'll end, either terminate or repeat. Okay? So rational numbers either terminate or repeat. And then the last thing is irrational numbers. Irrational number is a number like pi. Okay? Pi is a number that keeps going on forever without stopping. So irrational numbers are numbers that cannot be written in fraction form. You cannot write an irrational number in fraction form because when they're written as decimals, irrational numbers neither terminate nor repeat. They neither terminate nor repeat. Alright, so that's a review from yesterday. Remember, irrational numbers are decimals that keep going on forever without terminating or repeating. So, what example 1 says to do is it says to identify the subsets. Remember, subsets is plural. That means we are doing more than one of real numbers to which it belongs. So, I've got 15 and 2/10. I know if it's a decimal, it's not going to be an integer, it's not going to be a whole number, it's not going to be a natural number. If it's a decimal, it's either rational or irrational. I just need to know if I can write it as a fraction. Well, 2/10 I can write as a fraction. I can write it as 2 over 10, or 15 and 1/5. So if I can write it as a fraction, I know that that is a rational number. So I'm going to do the subset. Remember to put it in brackets. It's rational numbers, and then all the numbers we looked at yesterday are real numbers. We are classifying only real numbers today and yesterday. Okay? So it's rational numbers and it's real numbers. Alright? So those, because you can write it as a fraction, it's going to be rational. Now, negative 18. Negative 18 is not a whole number because it's a negative, but it is the opposite of a whole number. Now the opposite of, I'll move it over. The opposite of a whole number are integers. So integers, let me move this over. That would be integers, and then remember that chart. If it's an integer, you can follow that chart the same sort of way in your notes. If it's an integer, follow it up. If it's an integer, it's also a whole number. It's also a... Oh, sorry, I'm sorry. I said that backwards. Follow it down, not up. If it's an integer, it's also a rational number. So all integers are rational numbers because any rational number can be written as a fraction. Can you write negative 18 as a fraction? Yeah, all you got to do is put it over 1. All you got to do is put it over 1. Any number that you can write as a fraction is a rational number. So it's an integer, it's a rational number, and like we said, all these numbers that we are dealing with are real numbers. Be sure you put it inside brackets. So integers, rational numbers, and real numbers. Make sure everybody gets that. So integers, rational numbers, and real numbers. If you can write it as a fraction, it's a rational number. Now let's go to the back. It says identify the set of numbers that best describes the situation, best describes. Okay, so the first one, the number of people in Walmart. Well, can you have 0 people in Walmart? Yeah, it is possible. Can you have any number of people in Walmart? Yeah, that is also possible. So that's going to be whole numbers. All right. Walmart could have 0 people or any number of people. So Walmart could have 0 people, there could be 0 people in Walmart, or there could be any number of people in Walmart. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All those numbers, those are whole numbers. Alright, second thing, the area of a rectangular sandbox. Well, in order to answer that, we need to know the formula for the area of a rectangle. Formula for the area of a rectangle is just the length times the width. It's just the length times the width. So as long as the length and the width are not irrational numbers, now that's what we're assuming here. We probably needed a little bit more information to answer this question, but let's assume that the length and the width are rational numbers. Then, if you multiply 2 rational numbers together, your answer is going to be a rational number. So, my explanation would be assuming, so we had to assume here, assuming the length and width are rational, the product, remember product is what you get when you multiply 2 things. So assuming the length and width are rational, the product would be rational. So again, that's probably a little unclear. We probably could have gotten a little bit more information from that problem, but we could still answer it. Alright, we're just going to do one of these. It says 2. Determine whether each statement is true or false and give a counter example for false statements. We'll do the first one. The set of integers is closed under addition. So let's think of an integer. Let's go with 8. Let's think of another integer. Let's go with 9. 8 plus 9 is 17. Is that an integer? Absolutely. Let's try another one. Negative 8 plus, let's think, negative 10. Negative 8 plus negative 10 is negative 18. Is that an integer? Yes. All right. Let's think of one more. Negative 8. Let's stop using 8. Negative 5 plus 2 equals negative 3. Anytime you add 2 integers, all of those, I just added a bunch of integers, and every time I came up with an integer. So, true, because the sum of 2 integers is always an integer. The sum of 2 integers is always an integer. So that's how you know that it is closed. Remember, it's closed if anytime you add, because it talks about addition here, anytime you add 2 integers, you get an integer. That's how you know that it is closed. You can write skip on this last one, because we're going to go ahead and skip over that one. Alright, we are done.